Lesson number 7 looks at the ambiguous case of the sine law. So let's take a look at these two triangles. Scott and Brittany were told, draw me a triangle where side AC is equal to 4 centimeters, AB is 6 centimeters, and angle ABC is 30 degrees. Did they actually draw the triangles correctly? Use your ruler and your compass. I'll give you your ruler and your protractor, which I'll give you, and measure those measurements and see if they're actually drawn correctly. Okay. Are the triangles correctly drawn? Okay. So estimate what angle ACB would be. Without using the protractor, what do you think this measurement of this angle is going to be? So in Scott's triangle, what do you think it is? Hmm? 50? Okay. What do you think angle C is in Brittany's triangle? So imagine what a 90-degree angle would look like here. And how much more than 90 degrees do I have? How many degrees?
I'd say like
120 degrees? Okay, use your protractors now and tell me what you get. Okay, so what do you get for Scott? Got 50? What do you get for Brittany?
130.
What do you notice about the numbers 130 and 50?
Equal 180.
They equal 180 degrees. What quadrant is 130 degrees in? It's in quadrant 2. So if I drew a picture of 130 degrees, it would be like this. What's the reference angle? 50 degrees. So here's a relationship I have between those two angles. One is the 50 degrees could be the angle in question, or it could be the reference angle, and the rotation angle could be 130 degrees. So if we were to use the sine law to calculate these, the sine law would say sine 30 degrees is to 4 as sine C is to 6. That's how I would have this set up for Scott. I multiply both sides by 6. I get 6 sine 30 divided by 4 equals sine C. And to figure out what angle C is, I would have to inverse sine this answer. And what do you get when you do that? So what do you get?
49 degrees.
So then if I was to go to Brittany's triangle, if I use the sine law, I will get the exact same thing. I will get that sine C, not sine C, angle C, equals 49 degrees. But I know from the diagram that angle C has to be greater than 90 degrees. because it shows me that in that diagram. So angle C, this right here, has to be the reference angle. So then once I have the reference angle, I can then say angle C would be 180 minus 49, or 151 degrees. Now, in order to save some time, I'm going to skip over the next couple of pages, which goes through what do you need to know in order to know what this is, or to be able to do what is called the ambiguous case of the sine law. What ends up happening is this results in a possibility of two answers. Not every sine law calculation that we do is going to result in two answers. First of all, we need a certain condition. The condition that we need in order to have the ambiguous case of the sine law, go back to what we were given. What information were we given? We were given a side, and an angle. And this angle was not in between the two sides. So when we write it out, we can write it out as side angle, or if we wanted to, we could start off with angle side. You might want to write that one down and see what you get, because it might help you remember it a little bit better. I won't write it down because this gets published. So if I have side angle or angle side, I will have the ambiguous case of the sine law. But how do I know if I have one solution or two solutions? Well, that comes when we figure out the reference angle. The reference angle was 49 degrees. The given angle was 30. If the reference angle is bigger than the given angle, I'm going to have the possibility of two solutions. That's what you need to remember. Because the bigger angle is going to be opposite the bigger side. All of that gets kind of summarized on page 201. If the reference angle is greater than the given angle, there will be two solutions. If the reference angle is less than the given angle, there's one. And if the reference angle doesn't exist, meaning when you try to calculate it out, it doesn't exist, there can be no solution. Meaning you can't actually physically draw the triangle with those measurements. The other thing to note, if the side opposite the given angle is greater than the side opposite the required angle, there's going to be one solution. And if the side opposite is less than the given angle, there would be two. So if I go back to that example right at the beginning, this side opposite the required angle is bigger than the side opposite the given angle. Two solutions. So the bigger side opposite the bigger angle, there's two possibilities. Okay, let's look at the examples. Class example number 1. Without using the sine law, determine in which of the following cases there is exactly one solution to the problem. In other words, there's only one triangle that could be constructed. So if we think of this triangle, triangle ABC, I'm going to sketch it out because I like to be able to see it. I don't care if it's drawn to scale, I just want to be able to see it. Angle B is 56 degrees. Well, I can kind of sketch what 56 degrees is going to look like. There's angle B. So then side B is going to be 12 centimeters, so it's going to be quite a bit longer. So there's 12 centimeters. And then A and C, doesn't matter which one I do, I have 10. And this is 56. And what I want to know is I want to know angle C. So before we go to reference angles, we're going to go to sides. If the side opposite the given angle is bigger than the side opposite the angle you're trying to calculate, there is only one solution. So because side B is greater than side C, there's one solution. If I look at triangle PQR, angle P is 41 degrees. So that's kind of half of a 90 degrees, so something like that. There's 41 degrees, and that's angle P. R to Q, that's side P. That's this. And P to R is 4.2. And I'm asked to calculate angle PQR. So again, if I look at those sides, this time side P or side QR is less than side PR, which is my side Q. So if the given side with the given angle is smaller than the side opposite the required angle, there is not going to be one solution. At this point, I cannot state whether there is 0 or 2 solutions because I need to figure out the reference angle. The reference angle is going to tell me if there's 0 or 1 or 2. So the sides I can use to tell me if there's 1 or 2. The reference angle is then going to tell me, or sorry, if there's 1 or not 1. The reference angle is going to tell me if that not 1 is a 0 or 2. Okay, so I want to do class example number 2. So class example number 2 asks you to find all the possible measurements of angle C in the following situations. So triangle ABC where angle A is 50 degrees. So again, I like to sketch it out. So 50-degree angle, something like that. And that's angle A. Side A is 7.5 centimeters. And side C is 9.5 centimeters. So I'm asked to calculate this angle. So my given side A is less than the opposite, the required angle C. So if it is less, how many solutions will I have? If it's less, it's a not 1. So that means it could be 0 or 2. So now I need to use the sine law to find that reference angle, or find out if there is a reference angle. So we have sine 50 is to 7.5 as sine C is to 9.5. So I multiply both sides by 9.5, and then I'm left with sine C by itself. So then to find angle C, I would do the sine inverse of that answer. And I'll give you a moment to do that calculation and tell me what you get. What did you get?
76.
So because I actually get a measurement, we now know that there has to be two solutions, not zero. So there has to be two solutions. The one solution is 76 degrees. The other solution would be 180 minus 76, which would be 104 degrees. And I could easily check this out by going sine 50 divided by 7.5, answer, and then sine 104 divided by 9.5, and answer. And then comparing that, these two answers would then be the same. So let's look at the second example. Start off with angle A being 50 degrees again. Only this time side A is 9.5 centimeters and side C is 7.5. So because side A is greater than side C, there's one solution. So if there's one solution, I use the sine law the same as I would in every other question. So sine 50 is to 9.5, as sine C is to 7.5. So I'll give you a couple of minutes to try to determine that solution. So I multiply both sides by 7.5. And then I'll sine inverse that answer. And that'll give me angle C. And what did you get for angle C?
37 degrees.
And does it make sense that the smaller angle would be opposite the smaller side? Yeah. There's no way that it can actually be a bigger angle because this side is smaller. So that's the other consideration. Smaller angle is always opposite the smaller side. So the conditions that we needed for the ambiguous case, we need to make sure that we have side-side angle, where you reverse it, and then we look at what the sides are. Which side is longer? If the side that is opposite my given angle is smaller, there's possibility of two answers. If the side opposite that angle is bigger, there's only one answer. So your questions are not written down. I will find them. Question 3, 4, 5, and 6.